Hello students, I am Shanta Simukartihan, Selection Grade Lecturer, Government Polytechnic for Women, Bangalore. I welcome you all for today's session, Unit 1, ARM Embedded System and ARM Processor Fundamentals. Today I am going to cover the topics in this session are Introduction to ARM, ARM versions, features of ARM design philosophy, advantages of risk, disadvantages of risk, features of instruction set for embedded system, and I'm going to solve some MCQs. Let us begin our session with introduction to ARM. ARM is advanced risk machine. It is 32-bit processor and it is used for higher end applications. Example for higher end application is our mobile. The ARM processor core is the key component of many successful 32-bit embedded system. So in 32-bit embedded system, since ARM is a 32-bit processor, it is used. ARM was developed at Akron Computer Limited of Cambridge, England in the year 1983 and 1985. RISC concept was introduced in 1980. After the concept of RISC introduced, the ARM was developed in the year 1983. ARM is available in different versions, version 1, 2, 3, 4, version 40, ARM 7, 9, 10, 11, and ARM 7 TDMI version 40. The most popularly used ARM is ARM 7 TDMI version 40 because it has got a very good feature, that is it provides high code density and low power consumption. So you can see the different features in version 1 to ARM 11. So in version 1, the 60-bit, 26-bit addressing is there. Version 2, 32-bit result multiply co-processor feature is available. And version 3 is 32-bit addressing once again. Version 4, some additional features are added. That is signed numbers are added, unsigned half-word numbers are added, signed byte, and load and store instructions are available in version 4. And version 40, a special feature is included, that is 16-bit thumb compressed form of instruction. Now we'll study the different features of RISC. Let us study what is RISC stands for. RISC is an acronym for Reduced Instruction Set Computer. From this name only, the ARM has come, Advanced RISC Machine. So RISC is Reduced Instruction Set Computer. The features are simple operations executing in single cycle. So the most of the instructions are executed in single cycle in RISC. RISC processor use hardwired control. So what is hardwired control? In hardwired control, the control logic is implemented with gates, flip-flops, decoders, and other digital circuits. So for this reason, it is called as hardwired control. The control logic here is implemented with the gates, flip-flops, etc. RISC processors are uniform in size of the instructions. All the instructions are having uniform size. So fourth feature is they have very few instructions, and RISC uses limited number of addressing modes. The addressing modes and the instructions we'll study in the later sessions. The other features of RISC are RISC machine have large number of general purpose registers. Any register can contain either data or address. So any register, it holds either the data or the address. Register acts as a fast local memory to store data required for processing the operation. And CISC processors have dedicated register for a specific purpose. In CISC, we have dedicated register for specific purposes. But in RISC, the registers, they act as a fast and local memory to store the data. The data can be stored in a register where the registers act as a fast and a local memory. You can see the diagram in this slide. So I have given two diagrams, one for CISC and one for RISC. So in CISC, The greater complexity is there on a processor, you can see in the diagram. In RISC, the greater complexity is there on the compiler. This is the main difference between CISC and a RISC. So CISC emphasizes hardware complexity, whereas RISC emphasizes compiler complexity. So next topic is features of ARM design philosophy. What are the features? So using RISC architecture, the ARM is developed, and what are the features of ARM design? That we'll study now. So first I'll list the features of ARM design philosophy. They are low power consumption, high code density, low price, small size, hardware debug technology, and a core processor. So let us study one by one feature. The first feature is low power consumption. ARM processor consumes very less power. Because of this consumption of a low power, the battery operation is extended. So because the battery operation is extended, it is best suitable for the applications like mobile phone and personal digital assistants. The second feature is high code density. What is high code density? In smaller area, we can write more code, that is program. It is called as a high code density. Embedded systems have limited memory due to cost and a physical restriction. So the memory size is less because we'll check for the cost and physical size also. So therefore the embedded system have a limited memory, and therefore the high code density is the major requirement. Since the size is less, we need to do high code density. In a smaller area, we need to store more programs. So it is essential for applications. Where it is essential, smaller area storing more program, we need to have this feature in mobile phones and mass storage devices. So example for mass storage devices is HDD, hard disk drive. So in these two many applications are there. In these two applications, the high code density is required. So that feature is available in ARM design philosophy. So this feature is taken to develop the mobile phones and the mass storage devices. Low price. Embedded systems, so because they use slow and low cost memory devices, the cost is less. And this feature makes them suitable for high volume applications like digital camera. The size is small. So the feature is small size. Embedded processors use smaller area. More space is available for peripherals. So fewer discrete chips are required for end product design. And as a result, the cost of design and manufacturing is also reduced. Debug technology. ARM has incorporated debug technology within the processor itself. So software engineers can see what's happening while processor is executing the code with the help of this feature, debug technology. They can resolve some problems faster. So this will lead to reduction in overall development of time and cost. Core processor. ARM core is not a pure RISC architecture. So in the beginning, I told RISC is reduced instruction set, but I told that in a ARM, we are going to use RISC concept, but now we are telling ARM is not a pure RISC architecture. So what do you mean by not pure RISC architecture? Pure RISC means execution of each instruction takes single cycle. But in ARM, some of the instructions execution of the instructions takes more than one cycle. Therefore, it is called as enhanced RISC architecture. It's not a pure RISC architecture. So this is very important feature in a ARM design philosophy. The emphasis is improved system performance and low power consumption. Now we'll study what are the advantages of a RISC. Why the RISC should be used in a ARM? What are the advantages? RISC computer is much faster and more user friendly. RISC computer is more concerned with the software, and it uses single clock cycle for the execution, and it has got the reduced instruction set. RISC computer uses It's transistor for the memory storage. RISC processor is much faster and can achieve speeds that are 2 to 4 times faster than the CISC. So because of this, we are going to use RISC in a ARM. Due to its speed, more functions can be performed in shorter amount of time. Then what are the disadvantages of RISC? So I told that debug technology is included in a ARM. So it often requires debugging. It can make it tough for programmer to debug sometimes, and debugging requires more time and effort. And RISC has also limited code expansion, and RISC design places greater demands on compiler. So these are the disadvantages of RISC. Next, we'll study the different features of instruction set for embedded system. The earlier features what we studied, they are on ARM design philosophy. Now these features belongs to instruction set. So they are listed as variable cycle execution for certain instructions, thumb 16-bit instruction set, conditional execution, inline barrel shifter, enhanced instructions. So what is variable cycle execution? Some ARM instructions execute in single cycle, but few instructions take more than one cycle. For this reason only, it is not called as a pure RISC architecture. For example, number of cycles taken by load, store, multiple instructions. These instructions we'll study in the later sessions. There are instructions called load and store instructions. So they operate on multiple registers. How many? It depends on the registers being transferred. How many registers are transferred? Based on this the number of cycle varied. Transfer can occur on sequential memory address. Sequential memory access are faster than the random memory access. The code density is, due to this, the code density is improved, and since the code for multiple register transfer operation is common. For multiple register transfer operation, the code is common. So because the code is common, the code density is improved. Next feature is thumb 16-bit instruction set. ARM processor core is enhanced by adding 16-bit instruction set called thumb. So here you have to remember, ARM executes two types of instruction. One is ARM, its own instruction, it is called as ARM instruction set, and another it executes thumb instruction set. It supports thumb instruction set. So it is a 16-bit instruction set and it is called as thumb. So it permits ARM code to execute either 16-bit or 32-bit instruction, and 16-bit instructions, they improve the code density. So it has got two options. Either it can execute 32-bit instructions or a 16-bit instruction. If it executes 16-bit instruction, then it improves the code density. By how much percentage the code density is improved? By 30% over 32-bit fixed length instruction. Next feature is conditional execution. An instruction is executed when a specific condition has been satisfied. After satisfying certain condition, the instruction is going to execute. This feature improves the performance and code density by reducing the branch instruction. So there are no separate branch instructions like as we studied in 8051 microcontroller. Along with the instruction, there will be a condition. After checking the condition, the instruction is going to be executed. So this feature improves the performance and the code density also. The inline barrel shifter is another feature of instruction set. Inline barrel shifter is a hardware component. It pre-processes one of the input register before being used by the instruction. So due to this, the core performance is improved and the code density is improved. So in inline barrel shifter, what happens? For an operation, we need two operands. For any operation, we need two operands. One operand is directly given to the ALU. The second operand is pre-processed, then it is given to the ALU. So this feature improves the core performance and code density. what is barrel shifter, and what are its how many operations it performs, that we'll study in the later sessions. Now I'll justify how the ARM is suitable for mobile application only. The ARM processor is designed to be small. The design is very small. Because of this small design, it reduces the power consumption. So because of the low power consumption, it extends the battery operation. These are all we required for our mobile phones. We want our mobile phone to operate for a longer time. If we charge in the morning, so we wish to come throughout the day. So that feature is available in a ARM because the size is small and power consumption is less, and it extends the battery operation. And ARM has got the important feature high code density. So this feature also makes the mobile ARM suitable for a mobile application. And limited memory due to cost and physical size restrictions, and slow and low cost memory devices are used. An inline barrel shifter improves the core performance and code density, variable cycle execution for certain instructions, smaller size of ARM processor. All these features what we studied in ARM design philosophy and the features of ARM instruction set. So I have listed some few features. So these features makes the ARM suitable for mobile applications. So the first one you have to remember, reduction in power consumption and extension of the battery operation, high code density and size of the memory less, and low cost, inline barrel shifter, variable cycle execution, and smaller size. All these features makes the ARM suitable for mobile applications. Justify how the ARM is suited to perform DSP type of function, digital signal processing. So the enhanced digital signal processor instructions were added to the standard ARM instruction set. So in the fourth slide, I told ARM is going to execute ARM instruction set and the thumb instruction set. So here one more feature it has got. So the DSP instructions are also added to the ARM instruction set. So this makes and the 16-bit by 16-bit multiplication operations and saturation. So this, because of this feature, it is suited to perform DSP type of function. And these instructions allows faster performing ARM processor to replace the traditional combinations of processor plus DSP in some of the places. Justify the features that improves the code density. High code density for limited memory and physical size restriction. This feature is included to justify this statement. The ability to use slow and low cost memory. This is also one of the feature. Reduced size for reducing manufacturing cost and accommodating more number of peripherals. And ARM supports 16-bit thumb instructions. All these features makes the ARM that improves the code density. So these features that improves the code density. So after studying all these topics, so we studied the different versions of ARM, and we studied the advantages of risk, disadvantages of risk, and I also explained the features of ARM design philosophy, features of instruction set, ARM instruction set. After studying all these things, now we'll solve some multiple choice questions. See here, the first question is, which one of the following is not the feature of ARM design philosophy? So here, 4 options are given: price, debug technology, enhanced instructions, and code density. So if you know the features of ARM design philosophy, then only you can answer it. So to answer this, you should first list out what are the features of ARM design philosophy. So let me list the features of ARM design philosophy. They are low power consumption, high code density, low price, small size, hardware debug technology, and core processor. In this, the option C is not there, that is enhanced instruction. The enhanced instruction comes under the group features of instruction set. So here the question is asked, not the feature of ARM design philosophy. So the answer is definitely C, option C. Next question is, which one of the following is not the feature of ARM design instruction set? So to answer this question, you should know the features of ARM instruction set. Then you can answer it. The first option is thumb 16-bit instruction set, conditional execution, variable cycle execution for certain instruction, and price is there. So we know that price comes under the category features of ARM design philosophy. So definitely the option is D. You can list the features of ARM instruction set once again. See, these are the features of ARM instruction set. In this, the price is not there. So price will be the answer for that question. Next question is, the main importance of ARM processor is providing operation with dash. So you just see the options. 4 options are given: low cost and low power consumption. So we know that the best example for ARM is mobile. So we want to have mobile for the low cost, and we need low power consumption for that. Definitely, without seeing the other options, we can tick it. This option A is the right answer for ARM processor providing with the operation. Next question is, ARM core is not pure RISC machine. As I said, the RISC is involved or implemented in an ARM processor. So advanced RISC machine, as the ARM stands for advanced RISC machine, RISC is taken. But the statement says that it is not a pure RISC machine. We know that ARM executes, in ARM, the some instructions take only one cycle for the execution. Some instructions take more than one machine cycle for the execution. So because of that, we say that ARM is not a pure RISC architecture. Definitely, it is a true answer, and the option is B. So thank you. I'll meet you in the next session. Bye.